everyone. Welcome back to another exciting day mathematics. Whoop, whoop. Warm-up number 48 is on the screen. And just FYI, today we're moving on to transformations. Let's go. Let's go. We're done with the baby steps. We're moving on. So make sure you finish up that warm-up within the next 5 minutes. You are going to need a graph paper, also a little ruler from over there. There's little rulers in there. Look for them. And get a Cornell note ready, okay? Give you some time. Copy it. Number 1. What'd you get for number 1, please? Let's see. About Dylan, what'd you get? Okay, so x such that x less than -2. 4 is less than or equal to x. Hands, if you got that? That is correct. Number 2. Pass someone, Dylan. All right, free pick for me. How about Jaden? Jaden, what'd you get for number 2? X equals and x equals. X equals 1. Let's go from the corner. Hands, have you got that? That is correct. And by the way, bonus question. What are the 4 names of that? Let me give you the first one. Called solutions. Yes, that's one name. What are the other 3? Talk to your neighbor. What are the other 3 names of those? The other 3 names. No one will have Jaden help us out. Hurry up, hurry up. All right, Jaden, pass someone. We need one name at a time. Jose. There's solutions. All right, I'll help them out. X intercepts. Yes, that's another name. All right, Jose, pass someone. Jalen, another name. What is it? They were factors before when they were parentheses. They're known as roots. Yes, roots are the other name. We have one more left. Pass someone, Jalen. What? Zeros. Write those down, please, because we will need those pretty soon. They're coming. They're going to be coming. Just giving you a heads up. Number 3. Let's see. Alyssa, pass someone. What? Y equals mx plus b, which is f of x equals blank x blank. And I think JP's got this. F of x equals? Negative 3x plus 5. Hands, have you got that? That is correct. Let's go. All right, copy the agenda for today. Agenda, warm-up number 48, transforming functions. We're beginning our transforming functions road to the end of the school year. It's all about transformations, guys. And this is foundational stuff for pre-calc and calc. So those of you that are moving on to the next, make sure you have this down out cold. And tonight's home play is 6 problems. I'm going to give you 2 on the screen in a little bit, and 4 from page 41 that's in Canvas. Okay? So 2 problems. I'll show you those on the screen. And then 1 through 4 from page 41. Also, reminder, as we're moving along with transformations, this is where some of you start, like, kind of having problems. See what I did there? Problems. Anyway, make sure you show up for tutoring Tuesdays and Thursdays. It's free, by the way. I don't charge. Isn't that crazy? Do you guys know that I don't do tutoring for family members? Yeah. Okay. Free tutoring here. Anyways, last night's home plate is a gift from me to you. Thank you, Mr. Q. You're welcome. All right. However, I do want to go over number 7 through 10. So get that in front of you, and I'm going to get that one in front of me. Number 7 through 10, just so you can compare your answers. Let's see how you did. So here we go. And for the sake of time, I'm going to move along. As you're getting there, here it goes. Number 7, it says, find the function's average rate of change. Tell your neighbor what one word describes rate of change, and it rhymes with rope. Yeah, slope. All right, good. So what's the slope? Let's do A. From x equals -3 to x equals 2 on the function. So let me go to the function. X -3 is right here, and x -2 is right there. So from here to here, what's the slope? 1, 2 up, and 1 to the right, so my slope is 2 over 1. Check your work. Yes? All right. Let's go to B. I'm going to switch colors so you can see it. From x equals -2, x equals -2, which is here, to x equals 1. X equals 1 is right here. Let me go to the graph, right there. So to get from here to here, I need to go 1, 2, 3, 4, 5, 6 down. So my slope is -6 so far. And then 1, 2, 3 to the right. So my slope is -2. And have you got that by yourself? Yeah. And so on and so forth. So let me go to number 8. It says, on what intervals are the function's values positive? So we're going to compare this to the y values. So let's look at the graph. Okay? So we're looking at it through the lens of y. So look at the y values that are positives for the graph. Okay? So first of all, do you guys see that this part has all y positive values, yes? So what is the interval notation for the x values? From where to where is it positive? So your neighbor, from where to where are those positive values found in interval notation? From here all the way to where? Here, and that is what? -3 to what? -3 to -1. We have positive values of y right there. Okay. Next. Is that the only place? No. This is also positive. All right? Tell your neighbor from where to where. I'm sorry? No. You're just comparing it to your home plate from last night that you did. Okay. All right. So you know from where to where on our interval is that section positive? Then I'll call on Jalen to help us out. From where to where? Where does it start and does it end? I know Jaden's got it, but, you know. All right. So starting where, Jalen? For the x? Yeah. 2. Yes. Right there. Okay. Infinity, positive, and it's parentheses. That is correct. All right, and you get the idea for the other one, right? Where the intervals are what? Values are negative. So if we were to go to this one, values are negative, that means I'm going to look at this section and I'm going to look at that section through the lens of the domain. Okay. Next, look at problem number 10. It says, what are the zeros? You're like, hey, I heard that before, Mr. Q. All right, what are the zeros? Well, the zeros are x equals. Okay, where is this graph crossing the x-axis? It's crossing, oh, sorry, move this up. The x is crossing here, the graph's crossing there. So these are my zeros, where the graph crosses the what? The x-axis. So it crosses at x equals -3. Where else? X equals -1. And where else? X equals 2. Those are known as my zeros. All right? And once again, I'm giving you like little snippets, guys, because eventually we're going to get to some that look like this. Stuff like that, and I'm going to ask you for zeros and stuff like that. So, all right, we good? Yes, Mr. Q. All right. So, let me set this aside. Copy, actually get your phone, take a picture of this one. These are the two problems that are not on Canvas. So, take a picture of that. And on Canvas, you have page 41 on your Intro to Functions module. You are to do numbers 1 through 4. But like I said, and as promised, today we're starting with transformations. There they are. All right. So, with that said, here we go. Y'all ready? All right. Our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. So today we start with transformations. Like I said, today I'm only going to give you one component, and it's going to start building up from there. But I think the easiest, as I can put it, is like this. You guys seen the game controllers, right? And you know how the controllers have joysticks, and they have different components, and each part does something in a game. It gives you like a certain function. Like if I'm playing the, I don't know, what do you guys play now? Mortal Kombat or Star Wars? Battlefront? No? What is it? MW2, whatever. Each toggle has a different function. Today I'm only going to give you one, and it's going to start building up as we move along, okay? So make sure you get this one down cold. All right, so do we know what functions are? Yeah? All right, in your own words, tell your neighbor what functions are, in your own words. Tell your neighbor so I can call him someone. So I can call him someone. All right, Jalen, pass someone. Caleb, function.
Yeah, it's numbers that you use for graph.
Numbers that you use for graph, okay. But more specifically, for one input, there's exactly one output. Yes, I'll take that. Yes. How about relation? Remember, the key word is relation. That's another one that you need to know, okay? All right. So write this down in your Cornell notes. Parameter, what are they? Parameters are a number that transforms a function into another function. A parameter is a number that transforms a function into another function. Parameter is a number that transforms a function into another function. Now, I think the easiest way of talking about parameters is the following. Like I think you guys have the baking class here, right? Who makes cookies here? In that class, some of you? Yeah? All right, so watch. You start off with whatever mix, and then you make your dough, then you put it on your cookie sheets, right? But what transforms it from dough to cookies? The heat, doesn't it? The heat in the oven transforms it. That's what we call a parameter. But here, today, I'm going to give you a number instead of just being heat. It's a number that's going to transform a certain function into another function. That's basically as clear as possible. All right? So with that said, where have we been? Look up to the screen. We've been here. We started with two variable equations, y equals 3x minus 1. And I said we can make a table. Remember, we started making tables on the warm-up. And what values did I use for the domain? From -2 to 2, yes. And we got the y values. Is that correct? Yes, Mr. Q. Thank you for the extra practice. You're welcome. I got you. And then from there, I said no longer are we going to be looking at y. Why? Because now we're starting with what? Function notation. And we changed that from y to what? F of x. And I said it's only a label. We're going from y to f of x. There is no formula. We just rewrote y. Instead of rewriting y, we wrote f of x to indicate that we are now in function notation mode. What changes from the table? The only thing that changes is the letter y. There it is. It changes to what? F of x. And that's how it's going to keep going from now on. We're no longer going to use y anymore. We're going to use function notation. Okay? So, get your graph paper in front of you, and the medium-sized graph, we're going to start with a medium-sized graph so you have plenty of space, because we have to make 3 tables. Copy this one. Example Q. And it says graph f of x equals 3x minus 1 using the domain -2, -1, 0, 1, and 2. And I want you to make 3 tables. One in black for f of x. One in green for f of x plus 5. That's the first parameter. And one in red for f of x minus 2. That's another parameter. So copy that. I'll give you some time. Ready? Go. Here we go. So let's fill out the table in black, our original f of x. We know how to do that. So for tonight's home plate, when they ask you, when they give you a function, they want you to graph the function. You make a table. And then what do? Oh, we use our function. Okay. So then we use f of equals 3 parentheses minus 1. Have I been giving you plenty of practice of that? Oh, yes. Thank you, Mr. Q. You're welcome. I got you. So my first value is what? -2. -2. So we write f of -2 equals, what is 3 times -2? -6. What is -6 minus 1? -7. That goes right there. The next one, f of -1 equals 3 -1 minus 1. So f of -1 equals, what is 3 times -1? That's -3 minus 1, that's -4. And I said we need to show the work for at least 3, and then from there go with the rest, yes? So f of 0 equals 3 times 0 minus 1. So what is 3 times 0, guys? 0. What is 0 minus 1? -1. And now hopefully you see the pattern, yes? All right, fill in the last 2. The last 2 values with the pattern. If you don't see the pattern, then you need to do the work. All right, tell your neighbor the last 2 before I ask Valente. The last 2 values. All right, Valente, go. 2, and 5. Hands if you got that. All right, let's plot that in black. -2, -7. -1, -4. 0, -1. 1, 2. 2, 5. Get your little ruler that you got from over there and sketch your line nice and straight, going through those points. There it is. And since this is our initial function, we're going to label this one f of x. This is our original function that we're starting with, f of x. All right. Now, from experience, guys, I'm going to tell you that with transformations, most of you are going to see it just using the graph. But where it starts getting confusing for some of you is when we fill out the table. So that's why I'm gonna start with a table first. They're in that box. So with that said, writing utensils down, look up to the screen. So what I'm about to do, I'm going to transform this original function, this one, into a new function which I'm going to graph in green. Okay? So let me show you the mechanics of how to fill in that table. Ready? Here it goes. Writing utensils down, look up to the screen. So this says x, and if you notice, it's the same on all of them. Okay? The only thing that changed on this one, it says f of x plus 5. But Mr. Q, we already have f of x over here equals 3x minus 1. I get it. However, this is what I want you to do. I want you to look at this through the lens of the original. So here we go. When x is -2, I go to the original. What is f of x? -7. But then it says to do what? Add 5. So what is -7 plus 5? -2. Copy that. Next one. Let's look at -1. So I go to the original. -1's here. What is f of x on -1 of the original? -4. But that says plus 5, so that is 1. Finish the table, please. See if you get the pattern on how to do the rest. I'll give you some time. All right. Share with your neighbor, see what they got for the last 3. What did they get for the last 3 values of that table? Who went last? Valente? Okay. We'll start with Valente. All right. Valente, pass someone for x0 on the new transformation. What is our new value? Joel. That is correct. Hands if you got 4. Let's go. Pass someone, Joel. Jose, next one. 7. Hands if you got 7. That is correct. And the last one, pass one. Jaden? Oh, 10. Oh, he didn't even hesitate. 10. Hands if you got that. That is correct. Let's pop those points. -2, -2. -1, 1. 0, 4. 1, 7. 2, 10. All right, let's graph our nice and straight line in green. Make sure it goes through all the points. All right. Not bad. Now, since this one is no longer an original function, we can't label it f of x. So that means this one we're going to label it something different. We're going to label it g of x, g of x. So from now on, guys, anytime we do a transformation from the original to the newer one can no longer be f of x. We're going to label it g of x. Okay? All right. So far so good? Yes? We good? However, I want you to see something. Ready? Look up to the screen, write your utensils down or you're going to miss it. Here's my original function, and I started with 5 points. This one, this one, this one, this one, and this one. Okay. But my new transform function is this one. So imagine somebody walks in, and they have no idea what we're doing, and they don't know what we did over here, but they can see graphs. And you can say, okay, well, look at this one. This is our original one. This is our new one. What can you tell them happened to this one to get to here? Talk it over to your neighbor. What can you tell them happened to that one to get to the green one? Talk it over to your neighbor. What happened to each of those to get to the new one? All right, let's see. Jaden, pass them one. Fredo, what would you say to someone that walks in and they see this one, you tell them this is your original one, and then we got this one from here. What happened to this one to get to over here? What would you say happened to all those? From here to here. Okay, Frida. Okay, she said the +5, yes, but remember, they have no idea about the math. The +5 what? Can you elaborate for each of these? What? Isabella, what do you think? Each point was moved up 5 spaces. Let's see. 1, 2, 3, 4, 5. Let's go. Let's see this one. 1, 2, 3, 4, 5. Okay. How about this one? 1, 2, 3, 4. So that means that each of those moved up 5 steps. Let's see. What was the parameter? +5. And it moved what? Up 5 steps. So let's make a prediction. Look up. What's going to happen to the original now with this new transformation? Tell your neighbor, please. Yeah, it should go down how many spaces? 2. So let's use first math here to fill this in, and then we'll do the graph. So let's go and fill in that table. So here you go. At x -2, the original f of x was what? -7 minus 2, that's -9. The next one, at x -1, the original f of x was -4 minus 2, that is -6. All right, write the last 3 values. All right, tell your neighbor the last 3 values, please. They should be just about done. All right. All right. Juan, give us the next value, please. Negative what? -3. Hands, have you got that? That is correct. Next value, Jessica? 0. And the last one, Christina? 3. Hands, have you got that? All right, let's plot those. -2, -9. -1, -6. 0, -3. 1, 0. And 2, 3. All right, let's graph our line. 2, 3. And Julian right away, he's all like, yeah? All right, so let me graph that in red. Now, being that this is not an original function, this is a transform function, we could label it g of x, yes? But for the sake of you seeing all the notations, I'm going to label this one h of x, h of x. All right, so let's see. Did it move down 2 steps? Let's find out. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So yeah, this one moved down, and this one moved up. Okay, from 1 to 5, how comfortable are you with this? All right. So if I was to give you a function already graphed, and I didn't want you to use a table, but you just used a graph, do you know how to do transformation using a function given? All right, let's see how we do. Turn your paper over to the big graph, copy this. It's only 4 points. Plot those 4, make your n. And at the top, you're going to write example omega q. Instructions. The graph of f of x is shown, so you're going to label that graph f of x. Then it says, graph in green the new transformed graph g of x with the f of x plus 4. And then from there, graph in red a new transformed g of x with f of x minus 4. Let's see how you do with that. I'll give you some time. Copy and go. Oh, I forgot to get you guys started here with the graph. Hold on. F of x. There you go. All right. It's pretty good, right? So this is f of x. The new in green is going to be labeled what? G of x. And what's going to happen to the original? Well, here it is. So tell your neighbor what's going to happen to get the green one, please, really quick. What's going to happen to get the green one? No one laughs about anything. All right. So what's going to happen to the original one to get the green one, Valente? Up 4, yeah. So we go from here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And you label that g of x. Ooh-wee. All right. And right now you're working already on the red one, yes? From the original to the red one. Pass them one, Valente. I pick? All right, Valente. All right. That was good, right? But I have to do it. So we have our original right here, f of x, and we need to get g of x. What's going to happen to get the red one, Valente? If this one went up 4, what is this one going to do? Let's go. We go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And we're also going to label this one for right now g of x. All right. From 1 to 5, how comfortable are you with this so far? Okay. So notice today I only added one parameter. And what's that parameter? It either goes what? Up or down. Okay? So on your Cornell notes, write this form. This is the original transformation rule. Write it down. G of x equals fx plus k. G of x equals fx plus k. Now let's see if you see all the components. G of x means that it's been transformed, yes? And it's been transformed from the original. Here's the original, and what happens to the original? We add k. Now, what is k called by the way, we said it at the beginning and you wrote down what it was. What is this called when it transforms the original into something else? Parameter. Yes, anytime we have a number in the, we add or subtract a number to the function, it's known as a parameter because it transforms it into something else. So, tell your neighbor, what does k do to the entire function? In your own words. Talk it over to your neighbor, what does k do to the entire function? If I gave you any graph, what does it do? All right. Valente, pass them one. Juan, what does it do? It moves it in which direction? Up or down. So on the side, I want you to put an arrow going upward and downward. And next to the up, what are we going to write? Yeah, positive, yes. And downward, it's a negative. That is correct. So whenever we substitute a negative value for k, it's going down. A positive value for k, it's going up. Okay? All right, once again, this is the general rule, and it's going to continue growing, by the way. And like I said, this is the little joystick. Right now, we only have one button that we're going to use. What is it? One button, one joystick, Pac-Man, right? Only one. But then we get to Street Fighter, and all of a sudden there's like 4 buttons or whatever. Okay? Anyways, we good? Yes? All right. Switch to another little graph. And before we do the last part here, let me give you a function. Don't copy this. I'm going to give you the function f of x. Look up. Here it is. Okay, this is f of x, yes? All right. So I'm going to transform that, and I'm going to give you a new function. You need to give me a new function. Tell your neighbor what's going to happen to this entire thing according to this transformation. Tell your neighbor, please. Juan, pass someone. It's what? It goes lower by 23 steps. That is correct. It's going to go down 20. So does it matter what graph they give you? No, as long as you know the parameter that's going to move the whole thing. Okay? All right, so with that said, write this down. Example super Q. It says graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. You have a little graph, right? A little coordinate plane. All right, let me get a table going. So we got our table x, f of x, -2, -1, 0, 1, 2. And right now I'm giving you a soft introduction to quadratic functions. And now I'm going to take this function and I'm going to substitute each of these. So here we go. I'm going to write this right here, f of parentheses squared. All right, here we go. What's my first value? -2, -2. So, what is -2 squared? 4. There you go. Next value, f of -1 is -1 squared. What is -1 squared? 1. F of 0, 0 squared is 0. Fill in the last 2. All right, tell your neighbor the last 2, please. Make sure they got it. 1 and 4. All right, let's plot those points. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. arrows at the end like so. All right, y'all ready? Here we go. I'm going to switch to blue. And I want you to transform this, oh, sorry, let me label this one. This is our what? F of x. Here we go. I want you to transform that one to g of x equals f of x plus 3. Graph me the new transformed function and label it. All right. Show your neighbor your new transformed function. See what they got. All right, Alessandra, go. Tell me the new coordinates of the new function. Negative 2, 7. Negative 1, 4. Uh-huh. Uh-huh. And we label this what? Hands if you got that by yourself. Yeah, we got this, yes? All right. So, this is what I want you to do. I want you to write 1, but that it's going to go down and graph it. You make it up. One that goes down, and you make up the g of x and graph it. Alexandra, pass to someone. Who? Anaya? Which one did you write? Fx minus what? 5? Okay. Alex, what did you write? G of x minus 4, okay, and so on and so forth, yes? So Anayas moves this one to negative 5 right here. All right. So from 1 to 5, how comfortable are you with this? All right. So let me just adjust something from the home plate that I noticed. Hold on. Let me go back. All right. So for the home plate, you have the 2 problems that you took a picture of. Hold on. Look up. For this one, just close it here and close it here. Forgot to move the parentheses. Okay. All right. And for the page 41, I want you to do numbers 2, 4, and 6 instead of 1 through 4. 2, 4, and 6. All right. We'll stop right there. You good? Yeah? All right, let's go. And Monday we'll continue with more transformations. Once again, make sure you do your own practice. Stop copying from people. My goodness. And I'll see you guys till Monday. Bye.